I'm going to get started here on Unit 2, Day 1. This is exciting. Back in school. Hope everybody had a good summer break. I think it's time to do a little bit, though, so we can get it going, get our brains going for a little bit. We're going to start with some definitions for the current unit. The first definition is a variable, and that just is stating, oh, there it is. That is just a letter that represents a variable, or I should say that represents a value, sorry. A value. And you guys have seen this before in pre-algebra for sure. We have these letters like X, I think that's the most used one, Y or Z. Those are the three big ones that we usually see, but you can use any letter. Anything from A to Z would be a good letter. Then we have a term, and this is, oh, what's going on here? It stopped writing. Whoa. All right, let's see here. Let's see. Unit 2, Day 1. Sorry about that. I don't know why it hopped backwards, but I'll pull it up in just a second. All right, here we go. So we just did variable. We said that's a letter. And then we have a term. And a term is a part of an expression. And they are separated by plus or minus signs. And if I'm going too fast, the great thing is these are recorded, so all you gotta do is press pause or press rewind if I'm going too fast. So we have this expression over here, 2x plus 3. So that has two terms in it. The first term is this 2x. The second term is a plus 3. So there's two terms, and one is a positive 2x, and the other one's a positive 3. So that's what a term is. It's just pieces of expressions. And then we have coefficients next. This is the number in front slash attached to a variable. So typically, if we take a look at this example 2x plus 3, again, as an expression, the coefficient that we see, and the only one that we see, is this 2 in front of the x, because that's the only thing that's attached or in front of a variable. The variable is a letter. So 2 is the coefficient. And if there is no coefficient in front of a variable, so let's say that we have this example of x plus 3 over here, that would be an expression as well. We would say there's always a 1 out front if there's nothing written. You can always assume there's a 1. If we continue to move on, we have a constant next. This is a term that is a number only without a variable. So if we go back to that same exact expression that we've been dealing with, this 2x plus 3, you got to ask yourself, which one of these terms does not have a variable? And that would be this plus 3 part right here. So that would be considered a constant in that case. So anything that's just a number, 1, 2, 3, 4, 5, 6, or any negatives would be considered a constant because they don't change. Constant means there's no changing going on there. And then like terms. These are terms with the same variable and exponent. These can be combined in the end, which we're going to get to this unit. So if we have a 2x squared plus a 3x squared, well, do they have the same variable? Yep, they both have an x. And do they have the same exponent? That's the number on top of that variable on the top right. They both have a 2. So yeah, they are considered like terms. So that means we can take these coefficients that are out front, the 2 and the 3, and add them together. So we get a 5, because 2 plus 3 is 5. And the x squared stay the same. We don't do anything with those. So that would be my answer if we were going to combine them. And then we have unlike terms. And these are terms that either have different variables or different exponents. And these cannot be combined. So if we had a 2x squared plus just a 3x, those we can't combine. They both have an x, but they both don't have a 2 as their exponent. So that would be my final answer if it asked me to simplify that. Or another one that might be different would be like a 2y squared plus a 3y squared. And if you take a look at that, they have the same exponent, but they have different variables. So that means they can't be combined either. So if they ask you to simplify that, that would be your answer. There's nothing to do. So let's just take a look at an example here of all of these vocabulary terms kind of put together. So if we had 2x minus 5 plus 3x minus 4y. So the first vocabulary term was a variable. So let's talk about the variables that we see here. Well, we see there's a variable of an x and there's a variable of a y. So those are my two different variables I see. The terms in this expression are my pieces separated by plus or minus signs. So I have a 2x as a term. I have a negative 5 as a term. I have a positive 3x as a term and a negative 4y. So that covers that vocabulary term. My coefficients are always going to be the numbers that are in front of a variable. So I have a 2, a 3, and a negative 4 as my coefficients because those are all the numbers that are in front of the x and the y that I see. The next vocabulary term we had were constants. Those are the things that don't change because they don't have a variable attached to them. And I think I only see one constant here, and that's just negative 5. The next vocabulary term I have is like terms. Do we have any? Are there any that we can combine? I think we see a 2x and a 3x have the same exact variable and the same exact exponent of just a 1 on top. So those are actually like terms. And then unlike terms, these are the things that cannot be combined. Well, if we combine the like terms, we'd get 5x from up above. And then we'd have this constant of negative 5, and we'd have this variable with a y, so the negative 4y. So those would be all the unlike terms that we cannot combine. So that's all of our vocabulary terms on the first day. And then if we go to the back of your notes, this is going to be talking about combining like terms again. So we're going to revisit that. So let's go to the back. Oopsie. Whoop. let's not draw on that. Not yet. Oh, geez. All right. Okay, so it says when writing the answer, if we combine like terms, we need to make sure that we write in a specific order. In that order, if we take a look at this on the right side here, it's actually always going to be alphabetical in the end. So we write all my A's, then my B's, then my C's, and then so on and so forth. So in the end, it should always be in alphabetical order. And one thing that these notes don't say is after alphabetical order, then by exponent. So that means you write the biggest exponent to the smallest after you do the alphabetizing, which I'll show you. And then when a coefficient is not present, we talked about this on the front page. What do we always assume is in front of that coefficient? I should say in front of that variable. It's always a 1. So here's an example right here. It was 5 plus c. In your brain, just know that there's always a 1 in front of that c. And when you combine like terms, there's another way that the book might ask you to do that tonight. It might say simplify. Oopsie, that's misspelling. Simplifying an expression is what the book might ask you to do. It might ask you to simplify the expressions. So that just means combining like terms, trying to make it from a couple terms into one if possible. So if we take a look at simplifying, sorry, that's a G right there. So if we take a look at number 1, we have to figure out if these are like terms or not. The first thing that we have to ask ourselves is, do they have the same variable and do they have the same exponent? So they both have an x and they both have a 2 on top of that x. So that means we can combine them. So this 3 can be added to that 5. So 3 plus 5 would give me 8. And then the x squareds don't change. So that's an x raised to the second power. That's our answer for combining like terms. The next one, we know there's a 1 in front of that c since there's nothing written there. And I have to ask myself, are these like terms? Well, do they have the same variable and do they have the same exponent? So they both have a c and they both have a c to the first power. So that means I can combine those. Negative 5 plus 1 would give me negative 4. And then I have a c to the first power. And that would be my answer for number 2. Number 3 has a couple different letters here. So I'm looking for the ones with the same letters and the same exponents. So it looks like this A and this A have A's to the first power, so that means I can combine those. And that's 8A. And then this B and this B has the same exact variables and exponents, so that means I can combine those. And I remember there's always a 1 in front of that B. So that means I'm going to do negative 3 plus 1. That'd be negative 2b. And I did write this alphabetically, right? That's my final answer. If you take a look at it, the A's come before the B's. So make sure that you always do that. For this next one, for number 4, we have a 6x and a negative 11x. They both have the same variable and same exponent, so that means I can combine those. 6 minus 11 would be negative 5 in your calculator. And then we also have these constants that we can combine. That's a positive 2 and a negative 5. Positive 2 and negative 5 is a minus 3. And that would be my answer. If we think about the rule of alphabetical, the alphabetical x comes first because that's the first in the alphabet. And there's this minus 3 that's on the end doesn't have a letter, so you always write that last. So the constants are always last. So make sure we know that when we're writing our answer. We always write our constants last. So if we go on to number 5, we got 3 different letters here. Alphabetically, I believe QRSTUVWX is first. So we have this X and this X. So if we combine those, we'd get 14 minus 4 is 10X. Alphabetically, I think it goes x, y next. So we'll do our y's. There's always a 1 in front of that y. So we have negative 9 minus 1 would be negative 10y. And then z's would be last. So we have plus 3z and minus 3z. I think that gives us 0 z's. So those will cancel each other out, so we don't even need to write it. So that would be my answer there. If you write plus 0z, you wouldn't be marked off. But normally 0 times anything is gone. It just knocks itself out of there. The next one, if we look at the like terms, we have this 8 and this 3 have an x and a 2 on top of that x. So that means those can combine because they have the same variable and power or exponent. So 8 plus 3 gives me 11. We have plus 2 minus 3 gives me, in my calculator, I think they give me minus 1. And there is no constant. And I wrote that from biggest exponent to smallest. So the 2 came first, and the 1 would be next for our exponents. So that's combining like terms. Why don't you pause it and try to do the next few here. Do 7 through 9 and see if you can get the answers that I'm about to get. So press pause, try it out, and come back to me. All right, hopefully you did the next 3. Let's take a look. We have A's come before B's. So I have plus a positive 12a and a minus 12a. I believe that those would actually cancel each other out to give you 0 A's. So I don't have to worry about that. And then this B always has a 1 in front. And I have negative 4 minus 1. So if I have negative 4 minus 1, I'd be negative 5. And that would be my answer. So just a negative 5b to the first power. And then we have, for number 8, we have this positive x squared. I don't see any other x squareds. So that means I'm just going to write that. That's going to represent my x squareds. There's a 1 in front if you want to write it. We have this negative 2x and this positive 6x. If we combine those, negative 2 plus 6 gives me plus 4x in your calculator. And then we have the constants that are last. So we have this 5 plus 6. That would give us plus 11. And then that is written from biggest exponent to smallest with your constant last. So that's how we want to see it on your tests and quizzes. For number 9, alphabetically, we have the m's come first. So we do 4 plus 4 would give me 8m. The n's would come next. So that would be minus 4 and minus 4, and I believe that's negative 8. And the constants are last, and the only constant I have is this plus 4, so I just write that at the end. That's alphabetical with the constants last. So hopefully you got those 3 right when you took a pause. Now these last 6 are maybe the harder ones. So I'll do these with you. Hopefully they make sense. So the first one, I take a look at it and I see a 2x squared. I don't see anything else with an x squared, so that's going to be rewritten on its own. I see this x to the first and this x to the first. Those, if I add those together, negative 2 plus 2, I think I get 0 x's. So those cancel each other out. And this constant, plus 2, is the only thing that's left. So I write it as 2x squared plus 2. The next one, I know that there's a negative 1 in front if there's nothing written. So I have a minus 1 and plus 2 for the a squareds. If I do negative 1 plus 2 in my calculator, I believe I get 1a squared. I can add my a's together. I know that that a has a 1 in front if there's nothing written. So I have 3 plus 1 would give me plus 4a. And then I have this constant of negative 6. So now I have minus 6. And that would be from biggest exponent to smallest with the constant always last, like we talked about above. The next one, alphabetically, the x's come first. So I have an x squared and an x squared. So now I have 4 minus 1 would give me 3. And then I have my y's, which would be next according to my alphabet. So I have negative 2 and negative 3, so it's negative 5y squared. And then last would be my constants, would be 6 plus 1, that's plus 7. So that would be my answer from alphabetical, and my constants always last. Ooh, 13 has a couple variables attached. So there's a 1 in front of this xy for sure, because that's always the coefficient is a 1. And then the rest of these all have just an x and a y raised to the first power. So that means that they're all like terms and that you can combine all of the coefficients. So I have 1 plus 4 is 5. 5 minus 2 would give me 3. So I leave it as 3xy in the end. That's my answer. The next one, alphabetically, they both have an AB. So I would go with the one with the bigger exponent. So that's going to be the a squared b one. So I looked for another a squared b, and I believe I have one at the end, and there's always a 1 in front. So now that'd be 5 minus 1 is 4 a squared b. And then my ABs are next. So I have negative 10 plus 6. So that would be negative 4 AB. And that would be my answer in the end. That's alphabetical from biggest exponent to smallest. And then the last one, they all have an x and a y. So I'll go with the biggest x variable, or biggest x exponent first. So that's this x squared. Does another one have an x squared and a y to the first? Yep, this one right here, the last one. So it means I can combine those because they have the same exact variables with the same exact exponents. So 2 plus 8 would give me 10. And then this middle one would give me 3xy squared in the end. And that would be my answer, 10x squared y plus 3xy squared. So that's the vocabulary terms that we're going to need for this unit. And then it's the beginning of combining like terms. I'll see you guys tomorrow for the next day.